So my name is Sally Ann Williams. I work at Google on the engineering team. We're just down the road in Pyrmont. Last year we were actually fortunate enough to be able to host this event, but this year we're under renovations, which is proving to be a much longer challenge than anticipated. According to people, I think like any building renovation, it's going to take 3 times as long as the date they tell you. And we're really fortunate to be in CBA today to be part of this event. So what I want to do today is give you a really high-level overview, a little bit of the journey that I've had, a little bit about Google Australia, but also a bigger perspective of where we see the future of work going. This is something we're quite passionate about, and not just because of ourselves, but because we are very close, obviously, to the cutting edge of technology, but not just for Google's technology, but where we see work in itself in every industry and in every vertical shifting to. So just a little bit quickly about myself. I grew up on the Gold Coast. I come from a family of fruiterers. So my parents owned a fruit and veggie shop. I have a much older brother and sister. I'm the first in my family to finish high school, came through the state education system, was very fortunate to have people that really encouraged me, including my family, but didn't really have any role models ahead of me. So I was one of those kids at high school, first one in my family to finish high school, did all of the hard maths, chemistry, physics, English and Japanese, and had no idea what I wanted to do post-school, because I just didn't have a pathway or a clear thing. And I got some great advice from my family. You're smart, love. If you just work hard, you'll make your way, so don't worry. Which was really encouraging, but not incredibly helpful when you don't know where you're wanting to go or what it is that's an opportunity for you to explore. So they said do Japanese because you'll always have a job. And growing up in the Gold Coast at the time, that seemed like a logical thing to do. So I did an undergraduate and also a research degree in international relations and Japanese. And it was while I was writing my thesis that I talked to my best friend and said, I have to actually buy a computer because this thing, I have to write a book as part of my thesis, and I can't just keep going to the library because I will have to live there, and I don't think they want a bed in the room. And so she took me shopping for the weekend, and she did a computer science degree, and I expected her to take me to Harvey Norman or to some store and we would buy something off the shelf. She took me to this dingy little back alley in a components store, and we bought all of the components and the bits that go inside a tower, and she made me build my first computer, which was a very entertaining experience, highly enjoyable, and completely transformed my future career path and where I am today. So I am really grateful for her, and she knows that and gets lots of wine from me quite regularly as a thank you for changing the course of my future. So I'm personally very passionate about this topic. So Google's just around the road in Pyrmont. We have over 1,400 full-time staff here, and half of them work on the engineering R&D team with me. And we do a lot of work building global products and services from here. So Google Maps, how many people have used Google Maps? Excellent, hopefully you will enjoy it. That's actually a product that started here in Google Australia, and it was actually the start of our engineering office. So we acquired a tech startup company called Where2 Technologies, and they were the first 4 engineers in our office and the founders and the fathers of Google Maps. But we now work on Chrome, we work on Blogger, we work on Photos, we work on a ton of different projects here, and we are actually responsible during daylight hours for Google's production services being up and running all around the world, for security incident responses, for all sorts of things. So it's a really phenomenal opportunity. But computer science isn't everything, and it isn't the only career. So what I want to talk to you about today is the trends that we see going forward, CS plus X, and the careers of the future. Also, just to give you some perspective of the first few slides and what I'm going to talk about really fast, because I've got a lot to cover, so hopefully lunch fueled you up. Otherwise, I will get you energized. So just a little bit of context, I actually sit on the CoExTEM Partnerships Forum and work with our chief scientist to look at future trends and think about what we're doing in the space and making sure that we are at a government and an industry and an education level preparing students for the future and thinking about it not just for work but for research and for the future of Australia's economic base. And I really should have left my laptop unlocked. Anyway. So the changing nature of careers. So the world of work is massively changing. I feel like you probably heard this to death from people over the last few years. It's anticipated that students that are graduating today will have between 7 to 9 career shifts and 20 to 30 jobs in their lifetime. So there's no idea of this linear job of I'm going to go and graduate with 1 degree in 1 discipline and I'm going to end up working in that field for life. I have 2 degrees, neither of them in the discipline that I work from. So moving around and shifting around is something that is something already we know is happening. But for students that are graduating today, 65%, 65% of students graduating from primary school students in primary school today, when they graduate, are going to work in jobs that don't exist. So for us to prepare them for the future, we actually need to talk a little bit more broader than jobs and job classifications and job titles. And I think it really starts a conversation about skills and disciplines and merging of those disciplines and things. In the US, there's some really interesting stats. So the US is a little bit ahead of us in some of this. The economic crash that happened there, the global financial crisis, was a great leveler in a lot of ways, in the sense that it was a moment where a huge number of jobs were rapidly taken away and a huge number of jobs started to emerge. And so in Australia, we were kind of incubated, we were kind of isolated and insulated from that effect to a great degree. So the trends and the sort of challenges that we've seen in that place have been a little bit slower to be felt here, but it's super, super interesting. So 58% of all new STEM jobs in the US are in computing. So when we talk about STEM jobs and STEM careers, we're actually talking about careers that involve computer science predominantly. We're not talking about all STEM fields. The thing about it in the US, they've recognised this a while ago, and they've been priming the pipeline and getting more people to study dual degrees or computer science or do boot camp or do TAFE or do all those sorts of things. Yet only 8% of graduates, of STEM graduates over there, are coming out with computer science qualifications. And right now, I actually saw an updated stat on this. I believe it's 800,000 current job openings in America that require technical skills, that require computer science ability. Not computer scientists, I'll get to that in a minute, but require computer science capacity. It's in every single industry, and it's in every single state. So it's not just about working for the Googles and the tech companies in Silicon Valley. It's in agriculture, it's in finance, it's in mining, it's in commerce, it's in banking, every single industry. And those jobs are predicted, and they're growing at around 2 times the rate of every other job. In Australia, it's really interesting. When you look at Australia, the government's labour market projections to 2022 have growth in the ICT sector related jobs at over 21%, which is the highest growth rate of pretty much every sector. And we actually think that that's a little off, because they've actually kind of categorised them to graduation rates and to degree rates versus skills, and jobs that are kind of have skills in 2 areas and things like that. So I want to talk about data and skills, because I love data and I love big data. I think it's a really important way for us to have a conversation about the future and look at what are some of the trends that are emerging. And if you haven't seen LinkedIn's trends analysis that they do around the world of work, I'd encourage you to get on LinkedIn and go onto their blog and have a look at some of this, because they do this at a global level, and they also break it down to individual markets. So they do one for Australia. I think it's sometimes Australia, New Zealand. But what's really interesting is pretty much every year they come out with the top trends that they're seeing in hiring across the platform, or where the greatest demand is for jobs. And what's really super interesting about this is it actually gets into skills. So they're not giving you career titles, they're giving you skills. And so in 2018, at the beginning of 2018, these were the top hard skills that they said people were looking for and being hired for across LinkedIn globally. Now their data set is something like 450 million members. I think it's higher than that now. I'm pretty sure that's out of date, so have a look on there. So it's a significant data set, right? We can actually kind of look at this and kind of go, yep, that's something that I can kind of buy into and understand a little bit and kind of look at. So these are the top 10 that they said were needed. Cloud and distributed computing, statistical analysis and data mining, middleware and integration software, web architecture and development frameworks, user interface design, software revision control systems, data presentation, SEO and SEM marketing, which is really a large part of that is analytics, mobile development, and network and information security. And I think the thing about this skills list that's really, really super interesting is that it isn't in a particular discipline. The jobs that they were seeing people hired in across there that had these kinds of skills were in finance, they were in e-commerce. So, you know, we're talking about retail here. We're talking about people in marketing companies. We're talking about people in biomedical companies. We're talking about people in labs. We're talking about people in universities. We're talking about people at Google. We're talking about people in defense. You know, in every single area, they're looking for people that have these skills. Not these skills alone, but a plus X, plus something else, plus a disciplinary silo, or a disciplinary expertise as well in another field. And that's where we start seeing the real demand for jobs and emerging jobs that are coming. You know, everyone now is talking about data scientists and the importance of data scientists in work. What's fascinating to me is about how many career shifts you can do as a data scientist. I have a friend that is working with me now at Google as a data scientist, and he used to work at the RBA. And before that, he worked in e-commerce, and before that, he worked with a medical company doing things. And I'm like, it's a fascinating opportunity to take you into a really wide field that you can work in if you have some data science skills. And so these skills are really, really important for us to see. What's really interesting though is it's not those skills alone. So you'll hear a lot of people talk about 21st century skills or enterprise skills. They're often referred to as soft skills. I think that's a terrible phrase for them. I think some of these skills are actually the hardest ones that you can learn. And so one of the things that LinkedIn did this year when they came out with their data is they also went to 200 top CEOs from Fortune 500 companies and said, what are the things that you're looking for in your future leadership and your future workforce? And so in addition to the kinds of skills that we just talked about and those technical skills and those capacities, they said we're also looking for leadership, communication, collaboration, and time management. These are just not negotiable. We need this in the people that are coming through because the world is an increasingly connected place. It's increasingly busy, and we're expecting people to be able to manage themselves in a way that they've never had to necessarily do before because the complexity of what we're dealing with is greater than ever before. And so it's a really interesting thing what happens when you sort of merge those two things and think about them. So often the conversation I hear, and it really drives me batty, is when you hear people say, I'm just going to focus on these skills, or I'm just going to focus on the technical skills. The reality is if you work in tech, and I work in tech on the engineering team, every single day I have to stand and talk to my team. It's a highly collaborative environment. I communicate and spend far more time talking than I do spending time actually coding. You know, collaboration is absolutely critical. Nobody works in isolation. You have to be able to collaborate and communicate globally. Leadership is critical. If you're trying to get a product shipped out there, you know, it's not necessarily you're a manager, but everybody is expected to show leadership skills and capability, and time management goes without saying. We all could be better at time management. If anybody's a guru on that, my hat goes off to you. It's something that I always struggle with. And what I think is really fun when you start looking at what those two skills or what those two skill sets or those kind of two lists that I've spoken about, when you merge those two together, what comes up is individuals that are really good at problem solving and critical thinking. And they're actually able to take the technical skills, and you learn problem solving skills in all STEM disciplines, you learn it in the arts as well. But when you take some of those scientific principles and some of those really hard analytical skills, mathematical skills and capabilities, and you marry that with these other skills, and then you add a discipline to it like medicine or what somebody's passionate about, if they are passionate about performance or art or teaching, you end up with a cross-disciplinary expert. We talk about the T-shaped individual. I'm just going to make the assumption that you all know what I mean by a T-shaped individual. Does anybody need me to clarify that? Somebody who's really good at something at one particular area, but is a great generalist, a lot of a whole bunch of things. That's who we hire in our computer science departments. And we don't hire people that only do computer science. We are looking for breadth. If you talk to the team here at CBA, I've got a lot of friends at CBA. My husband, full disclosure, my husband actually works in this building, and wasn't sure if he wanted to come and say hello to me when I was coming down here, so that's a bit of fun. But you know, when you talk to people at the bank, they're talking about people that have skills beyond finance. They want them to have technical skills. They want them to be well-rounded individuals who can articulate and communicate and can translate and move as the world of work moves and move with it. So it's super important. So I want to give you an idea about what I mean by CS plus X and why I don't talk about STEM or STEAM, which I know will antagonize a bunch of people in the room, and I'm okay with being provocative. So for me, STEM and STEAM are too limiting. We're still thinking in disciplinary silos. And the reality is that the future economic base of every single industry is moving digital, if not has already moved digital. So if you're talking to farmers, you're talking about ag tech, you're talking about smart farming, you're talking about sensors in the ground, you're talking about automatic bug spraying and weed checking from drones and things like that. So you're combining agriculture and tech. It's neither either or, it's merging of those things together, and tech is a real enabler of efficiency and human capital. So we talk about CS plus X, and the reason that we put where X is the problem that you're trying to solve, your passion or any other discipline. And the reason that we still put X second and not first is because in this country we have a massive shortage of people who are technically capable. So we only graduate about 4,000 computer scientists a year in the country still, and yet the job opportunities are at least 3 or 4 times that right now. And it's not just about software engineers and computing science graduates, it's people that come through with marketing backgrounds and have deep big data analytics capabilities, or some basic data science capabilities to be really effective in their marketing careers. So it's neither either or, but it is really about a merge and a blend across disciplines. So let me give you a couple of examples to kind of just illustrate how I see this playing out in the future. So this is an example from New Zealand. There's a team at they're at the university in Wellington, Victoria University, thank you. I knew somebody in my room, Karen, would have my back. A team at Victoria University in Wellington works on nature conservancy, and they're trying to track and support and understand these birds that are unique to particular areas in New Zealand, and to support the preservation of the species. And so they have years, they have about 30 or 40 years of data of bird calls from sensors that they've put out in the field everywhere. The challenge that they had when they are not thinking about it, they've kind of gone, we've gone the first step in tech, but the challenge that they had was they deployed sensors, but they didn't know what to do with this massive data set that they'd collaborated with, that they'd got. So we actually collaborated with them, and we have an open source project called TensorFlow that is basically machine intelligence learning. It's machine learning, it's artificial intelligence, where they could model on their own machines in their lab, they could suck up all that data, and they could basically say, in layman's terms, they could say to it, what are the patterns that you see? What do you see? What can you tell us? What can you infer from all of this data? And so they actually figured out the migration patterns of these birds. They figured out where things were at risk. They could pick up other sounds. They could go, what was that anomaly that something happened then? And they could go back and check it. And so they're actually creating these massive models and being able to then go with and work with field officers and work with people to actually set up and preserve the landscape that these birds live in, right? That's the perfect blend of computer science plus, well, a whole bunch of different sciences really when you're thinking about preservation and conservancy and things like that. That's what we mean by CS plus X. Let me give you another example. This is an image from our crisis response page, and crisis response, or CS plus crisis response, I think is a really, really interesting one. We never thought at Google that we had a role to play other than, you know, giving and serving and volunteering. We couldn't figure out what our role to play was in a disaster. We just didn't think. We're like computer scientists. We're not medics. We're not disaster response agencies. We have no skills to give. We sit behind computers all day. And what happened became very real for us when the bushfires happened in Victoria a number of years ago, and Black Saturday. And we saw that the website, the Royal Fire Service's website, fell over because the load of people trying to find out information of what was going on just was not built to hold that and to deliver back on it. So it was serving 404 errors. And what was super interesting was the human response that we had of what can we do, what can we do, what can we do? Amazingly, thank goodness I work with really smart people, and one of them woke up and sort of, you know, pinged me, I was in the US, and said, we can do this, we can put up a disaster map. The one thing that they can't do, because they're not technologists, we can do, that's what we're good at. And I was like, great, let's do it. So we got a data feed, we were able to work with our product team, and within 12 hours we shipped our first disaster mapping response in Australia, our first crisis map. And we linked to all the emergency services, we showed where things were happening, we linked to news agencies, and we most importantly linked to the 2 organisations that had already got donations hotlines up there to take money and take services from people to help with support in that. And so it was this really interesting blend of we are specialists in what we do, disaster response people are specialists in what they do, but when we stand isolated and we don't come together, we don't empower each other to be more effective in how we can actually help really save and protect and preserve and do good things for humanity. So since then, we've been involved in a whole bunch of crises around the world. Most recently, I had a product manager who spent 6 months working with Médecins Sans Frontières a few years ago on a deployment in the field to deal with the Ebola crisis, because the challenge that they were facing in the field was between the exclusion zone where the patients were and between the other tents where a lot of the staff were and the records were. They were having to, you can't take anything in and out. And so they couldn't set up a mobile network, they couldn't have sharps in there, they couldn't have all sorts of things. And they were literally shouting patient records across a 10-metre exclusion zone. And so we shipped him over there and he walked around with them and he's like, what are your greatest problems? What are your greatest problems? And they were like, we are so slow at communicating and patient outcomes because of this. And he was like, I think we can solve this. And so he custom built, he worked with a bunch of hardware manufacturers that, you know, we obviously have close relationships with, to build a case for a tablet device that would be able to be literally dipped in almost acid and be carried out, deployed, a whole bunch of new plugs and charging stations that we built that would not interfere with or burn or hurt or cut anybody's protective clothing in there. It was literally a 6-week rack of prototyping that they now use in fields wherever there's something like that that's highly contaminated area. And it's that merging of those two disciplines and bringing it together that actually creates an opportunity for growth and for really innovative ideas to emerge. So it's that disciplinary excellence. The last one I want to kind of leave you with, and why I think this is a really exciting thing to talk about, and especially to talk about with students, is when you're young, you have no idea of what is impossible. There is a certain level of brilliance in naivety. And so every year we run a program called, or it's nearly every year, called the Science Fair, the Google Science Fair. And this is a photo of Anne Makasinki, and she won in 2013. And she had watched what happened in crises around the world where people were living in tents and there was no power and they had no light, and yet sometimes in refugee places they could be living there for quite some time or after a natural response. She's like, people cannot read, students can't read a book, they can't study, they can't engage in anything, there is just no light. She actually figured out on her own, she was aged, I think she was aged about 13 or 14 at the time, how to build a flashlight that was powered by the heat radiating from your body. She had no idea that this was a hard challenge or this was impossible. There is a brilliance in naivety that if we can somehow inspire our students to consider and think about, and to think about computer science as more than software engineering, to think about science as more, or medicine as more than just being a doctor, well that's great if you're really passionate about being a doctor. But to think about these things, about the skills that they really want to learn in these disciplines and the big problems that they want to solve in the world, and merging those things together with a technical capable, technically literate individual is somebody that could change the world. And these people are going to have all of these skills in addition to the technical skills. They are going to be critical thinkers, they are going to be problem solvers, they're going to be people that are going to bring people together to collaborate and do that. And that's the kind of individuals that we are hoping will come through, join us, join other organisations, and more importantly for me, if they could build the next Google here so I can get in pre-IPO, that would be awesome. And I'll go work with them. So thank you.